Continuing with the factors in the infectious diseases emergence, we can find the microbial adaptation and changes. So this corresponds to microbial evolution and the response to selection in the environment. And so the emergence of antibiotic-resistant bacteria is a result of the ubiquity of antimicrobials in the environment as an evolutionary lesson on microbial adaptation, as well as a demonstration of the power of natural selection. A classic example is influenza. Regular annual epidemics are caused by antigenic drift in a previously circulating influenza strain. This disease can be transmitted from swines and some birds to humans, causing what is called the influenza flu, which can be sometimes very infective and sometimes not that much. That depends on the strain. Another factor is the breakdown in public health measures. This includes the reduction in prevention programs and inadequate sanitation and vector control measures. An example of this can be cryptosporidiosis, which caused an outbreak in the US in 1993, where over 400,000 cases were estimated, and it was in part due to a non-functioning water filtration plant. Similar deficiencies in water purification have been found in other cities in the United States. And Cryptosporidium is a parasite an intestinal parasite that infects a variety of animals, which, for example, cattle, sheep, rodents, cats and dogs, and also birds, fish and reptiles. Human infections usually occur due to a species that also affects these domestic animals. In humans, infections with symptoms are common. Especially healthy individuals may, after an incubation period averaging one week, get a diarrhea that spontaneously resolves over a couple of weeks. By contrast, patients with impaired immune system may develop profuse, life-threatening, watery diarrhea that is very difficult to treat with currently available drugs. Person-to-person or animal-to-person disease transmission occurs mainly through contaminated water and food. The Cryptosporidium eggs can survive for months in moist soil or water and survive harsh environmental conditions, like heat, cold, and droughts, for extended periods of time. Now I'm going to talk about emerging infectious diseases, or AIDS. Some important facts is that of the 1,450 microbial diseases affecting humans, 61% are zoonotic. Among AIDS, 75% are zoonotic, being wildlife the major source of these diseases. And of 534 zoonotic viruses identified, 120 cause human illness, which can be directly or indirectly transmitted. One Health is defined as a collaborative, multisectoral, and interdisciplinary approach which works at the local, regional, national, and global levels, with the goal of achieving optimal health outcomes, recognizing the interconnection between people, animals, plants, and their shared environment. This One Health concept is not new, as its origins lies in the idea that there is no line between humans and animals when it comes to health and disease. Some of the history is in 1761, when the first veterinary school in Lyon, France was founded. Claude Bourgerot emphasized the importance of comparative biopathology. Just to mention, this school was primarily established to combat an epidemic of rinderpest that was a very fair disease of cattle at that time in France. Following the establishment of this school, some other veterinary schools were soon opened in other countries in Europe and later in other countries around the world. And in the 19th and 20th centuries, one of the main focus of veterinary education was on training veterinarians to control disease in food-producing animals to prevent the transmission of zoonotic diseases. Some years after, Rudolf Virchow, William Osler, and John McFadden incorporated veterinary perspectives into human health care through their respective work in comparative medicine, veterinary pathology, microbiology, and veterinary and medical education. In the 20th century, veterinarians Carl Mayer, Calvin Schwab, and James Steele maintained this inclusive approach through their work on public health and zoonoses. Schwab and Steele use the term One Health, One Medicine, One World, One Medicine, One Health to refer to their interdisciplinary work, but ecologists and environmental health experts were not included in this work. So while the pioneers of the One Health concept recognized that environmental factors played a crucial role in the well-being of humans and animals, the value of environmental health for the benefit of the ecosystem itself was not emphasized until 2004, when the Wildlife Conservation Society extended the One Health concept to include ecosystem health. The Wildlife Conservation Society listed 12 recommendations or priorities to combat health threats to human and animal health in what are called the Manhattan Principles in that same year. One Health approaches can be categorized as direct or indirect. The direct approach is exemplified by multidisciplinary teams which come together in the field to work side by side in solving an emerging disease problem. While the indirect approach occurs when specialists in different fields work on a component of a One Health problem and share the results through information exchange. Most disease outbreaks or epidemics are investigated by a combination of the direct and indirect approaches, with several types of multidisciplinary teams being assembled for different aspects of the investigation. This is probably the most common approach to practicing One Health today. Now, with the spate of viral diseases that emerged in the first decade of this century, which focused the need for One Health in the control of emerging diseases, also drew attention to the importance of reservoir species, particularly wildlife, as a source of epidemic disease in humans. Identifying potential agents in wildlife species that are capable of jumping species to cause disease in humans and domestic animals is a difficult task and falls within the arena of ecosystem and wildlife health. The health of humans, domestic animals, wildlife, and the ecosystem are all intertwined. Interactions between the three elements are multidirectional and they may be direct disease interactions or the side effects to control strategies. Ignoring these relationships or downplaying their importance has created unintended consequences to each side of the triad. Domestic animal health may be impacted by diseases within wildlife reservoirs through the direct effects of the disease and or the resulting control measures. Antibiotic resistance is just one example of the way in which failure to honor the connection between livestock and human health is now affecting our own well-being. Anthropogenic environmental disturbance has the potential to impact both domestic animals and human health. Ignoring the links between human health campaigns and ecological health can be equally disastrous for wildlife health. As a conclusion, it cannot be predicted which zoonotic pathogens are likely to emerge next or cause the biggest problem. Given the obvious link between human health and pathogens that circulate in domestic animals and wildlife, we must be alert to pathogen flow in any of these areas. In addition, a number of human activities undertaken with the best of intentions may have harmful potential. For example, the food and farming industries increasingly use antimicrobial agents and other types of drugs to boost the efficiency of food-producing animals and to prevent certain troublesome organisms from reaching consumers. Use of these chemicals probably enhances the proliferation of antibiotic-resistant microbes. Besides, the use of non-human animal cells or tissues in humans for therapeutic purposes may inadvertently introduce new zoonotic infections to recipients of such material. These, in accordance to the factors that lead to emerging infectious diseases, are some consequences that have to be in mind and that we have to address in order to control and prevent zoonoses. Thank you very much.